Okay, 3-1 reflections. Reflections are a type of rigid motion. A rigid motion is a transformation that preserves. What does preserves mean? Keeps. Ever heard of like preserves like jelly?
Yeah.
Okay, same thing. It keeps it. So preserves lengths and angle measurements or angle measures. Oh, I can't have an S on one and not on the other, so I put it off. Okay, so a rigid motion keeps lengths and angle measures. So this is what I'm saying. You know when you put a picture in a Word doc or on PowerPoint or whatever, you put a picture in and you want to change the size of it. What happens if I pull just the side?
It gets longer.
It distorts it and gets it longer, right? But what happens if I grab the corner and drag it?
It keeps its shape.
It keeps its shape. Same kind of thing, a little bit. Okay, so but we got to keep lengths and angles, yes? So pre-image means where you start. Image is where you finish. So is this a rigid motion? Did the length of the sides and the angles of the corners stay the same?
No.
Yes.
Yeah.
No, you're
it's
supposed
just
to.
flipped.
I just turned it, right? I didn't say anything about not being able to turn it. I'm just like, did the lengths or the angles change?
Yeah.
Yeah.
No.
Look on your paper.
No,
Look,
No, sorry.
look on your paper on the screen. It may look a little distorted.
They didn't.
Okay, so this is a rigid transformation. Now I will say, sometimes you do need to look at the paper because the screen will make it look funky. Okay, but this on B, pre-image to image, from here to here. Are those the
Juniors that
same?
have computer chargers
Yeah.
checked out need to be sure to bring the charger to school tomorrow.
What?
Also, all
What, Jacob?
juniors will be leaving computers
It's large.
Tuesday.
What did I
to get
say?
their charged
Lengths
ready to
and
go Wednesday.
angles
So
stay
have
the
that.
same. So if this is larger,
Juniors
that
have
means
computer
this
chargers
length is
checked out
longer
need
than
to be
that
sure
length,
to
isn't
bring
it?
the charger to school tomorrow.
So is it a rigid motion?
No.
No. So no,
No.
and you have to say why.
On your.
Well, okay, what do you want to say?
It's like wider. They just made it bigger.
The side lengths are longer? Could that be?
Yeah.
Okay, now, and this is just appear to be longer, yes, but it's pretty, I mean, it's pretty evident. Yes,
Can I please sharpen my pencil?
yes.
No.
Okay, so,
Stand
no,
right with this. It's too fat.
okay. A reflection is a transformation that reflects. I know you've probably all learned not to put the word in the definition. Each point of a pre-image across a line of reflection. So if I have an object here and I want to reflect it across this vertical line, each point is a distance from that line. Yes? So whatever this distance is, I have to do it again and put a new point. And this distance and put a new point. And then I would have it's reflected. So this would be A, B, C, D, and we would call this A prime, B prime, C prime, D prime.
Why are they called prime?
Because it's changed in geometry. Anything that's been transformed has a transformation on it. We put a prime on it. So if we would do it again, it'd have double prime. Like if we moved it again.
Okay.
So it's a way also to know that actually, I did that wrong. It's a way to tell A corresponds with A, and no one caught me that I did this wrong. It's a reflection. Shouldn't A be furthest from it?
Yeah.
Yeah. Okay, it's a way to tell which points correspond to which. So that's a vertical line. Well, if I did a horizontal line and I reflected it, it'd be like this, yes?
Like on water.
Okay, it would be like that. This farthest point is again farthest away. So that's nice and easy when we're vertical or horizontal, but when we're not exactly vertical or horizontal, we have to do some other methods to find it. Okay, is everyone good? Okay, so when that happens, let's look at this picture. We're not going to write anything yet. We're going to look at the picture. So A is the image, the red is the image, the black is the pre-image where it started. Okay, so we're reflecting over line M. Can everybody see that? That's reflecting over line M. And it shows me that A is equal to A prime because that happens to fall where? Right on the line. Okay? So when that happens, it is a point. So it's a point. And A would be equal to A prime because they're on the line of reflection. Well, when that doesn't happen, we have to connect the two. See this? And it makes a what angle with the line?
Right.
A right angle. And what do I know about this length and this length? They're the same. So if you don't remember, that's called a perpendicular bisector because it meets at a right angle and it cuts it in exactly half. Which is kind of difficult to do, but we will do it on a grid. So what's nice is we go down and over till we hit the line, and then we go down and the same amount we went down and over the same amount. So once you have a grid, it's not too bad. It's like a slope. You go down and over, go down and over. Same thing. See these little right triangles I made?
Yeah.
They're congruent triangles. So then I would do this one, go down and over. So then I go down and over, and I would get my second point. So there's some different ways we're going to do that. And we're not going to do it tonight, but there's some different ways. So we got reflection rules. So if the point A lies on the line, then A equals A prime. I already went over that. It's a point, right? If point B is not on the line, then M is the perpendicular bisector of B prime, the segment B prime, and C prime. So both of those, okay? So you should be able to draw a line, but then you'd have to do the distance formula. We're just going to put them on a grid. We're going to make it easy. How about that?
Is there an R
What?
in perpendicular? Is there an R?
Yes, there is. I just decided not to write it. Okay, so that's when it's not vertical or horizontal. So the last slide I did the vertical and horizontal. Which one's easier, vertical and horizontal or just some random line? Vertical or horizontal. Okay, reflection across line M, we write it as this. Capital R stands for reflection. A little m tells you what you're reflecting across. We're reflecting across line M. And then we put what we are reflecting. Oops. We are reflecting a triangle called A, B, C. And then triangle ABC turned into triangle A prime, B prime, C prime.
And they're always capital letters, right?
Yes, vertices are always capital letters, yes. This M can change. It could be like R and then 2x plus 7. That's like y equals mx plus b. And that would be your line. It could be R of y equals 3. That'd be a horizontal line at 3. Yes. It could be R of x equals -4. Well, that'd be a vertical line at -4. See how those things work? So it's R stands for reflection, and down here is what you're reflecting over, and then in the parentheses it will say what you're reflecting. Okay? The last we're going to do today is this. A reflection is a rigid motion. So, length and angle measure are preserved. So, what is that? Another word we could put? Keep or kept, because it's past tense. But, so we're keeping it. So, rigid motions keep all those things. So, some basic ones that we do a lot are reflections across the x and y axis. So a reflection of any point xy across the x-axis is the point x negative y. So an example of that is our x-axis of -7, 6. So the rule says keep my x, correct? Just says x, so -7. And what do I do to my y? Negative. So that means change the sign, yes? So it's +6, so it's going to be -6.
But why doesn't the -7 change?
Because the rule just says x. Whatever the x is, you keep the x. And there should be a parenthesis there, it got cut off. Okay, reflections point across the y-axis is -x, y. So reflect across the y-axis of the same point we just did. Give me 1 second, guys. -7, 6 would be 7, 6. Highlight this right here. You do not have any homework tonight. Okay, we'll just put today's and tomorrow's together because today's was like 3 problems. Sound good? Okay, have a good night.
Do you have one of those papers?